Tamarai Selvi is working as a professor in the Department of Computer Technology, MIT campus of Anna University, Chennai. She has over 30 years of teaching experience. Grid computing, cloud computing, and e-learning are her areas of interest. She has successfully completed 12 research projects funded by Government of India and Tamil Nadu state government. She has established Center for Advanced Computing Research and Education and acquired one patent and has filed for 3 more patents in her research area. She has presented over 110 papers in international conferences and published 45 papers in international journals. She has authored 5 books. The latest book is titled Mastering Cloud Computing, published by Morgan Goffman Publishers 2013.
Welcome to UGC lecture series on computer science. We are discussing about the topic on cloud computing, and now in this episode mainly based on the virtualization, what are the various benefits to cloud computing, that is what we are discussing. And also now in this episode we are going to see some more research activities in which we have used the virtualization concept. So, already I have discussed virtual cluster development environment in the previous episode, and also how to make use of the virtualization for creating the virtual machine form, and whenever there is a need how to interact with that virtual machines with the existing SunGrid engine, that also we have discussed in the last episode. And today we are going to discuss some more applications based on the virtualization. One such application is service oriented care resource broker. Already we have discussed about care resource broker in the last episode. Mainly we were focusing our attention for grid computing. Now this service oriented CRB, it was meant for migrating from component based architecture to service oriented architecture to accommodate the latest developments in grid computing. And the second one is to add resources leasing feature using CRB to support cloud paradigm. How to lease the resources from cloud, that feature also we have incorporated in this. So, if you see the layered architecture, here we have added that VCS and VRAS, virtual cluster service, virtual resource aggregation service, these two services we have written. Then we have written the VM adapter, because that virtual resources should be connected to this virtual resource manager. That adapter also we have developed in addition to the previous CRB. Then we developed the virtual cluster manager, virtual machine creator, then the physical resource information, virtual resource information, so that it will be having the information manager. Then you are having the virtual resource manager in which network server is also configured. Then we had the various operations in the request handler. Actually, whenever the job is submitted, the request handler receives the input, then it is submitting to the controller. The controller is having one component called action manager. The action manager is going to divert the next action based on the received inputs. Whenever a job is submitted, immediately it will send it to the host identifier, so that to which machine it has to be submitted. For that, scheduler is linked. But prior to this operation, the information manager will give the information to the controller about the existing resources. So, by checking the available resources, the action manager will give the request to the host identifier to identify in which resource the job has to be submitted. With the help of scheduler, it is going to identify the resource. Whenever physical resource is not available, then virtual resources are created even in the cloud platform also, and those things are attached to this one. So, this is the main contribution we have added compared to the previous thing, and we use the Eucalyptus based cloud platform in which we have created the virtual machine as well as virtual cluster, and the actual functionalities. The controller takes care of the decision to schedule the job. The monitor actually gives the various monitoring of the virtual resource creation, and the services for the VCS, virtual cluster service, as well as virtual resource aggregation services also implemented by us in addition to the previous existing CRB, but everything was made as service oriented. Now, you are having the head node in which the actual VCS selects the potential computer nodes to boot the Zen virtual machine. From which machine you have to create the virtual machine, that is identified by the scheduler, and the actual virtual machine is also created. After the creation of the cluster, the necessary grid middleware is configured, then LRMS, local resource management system, is also configured. Everything is done automatically, no human intervention, because once the job is submitted to the grid or cloud, the user is not having any control to it. Only the resource broker has to control the various resources given. So, everything is done automatically. It is the machine is created new, then you have to configure it for the cluster, that is automatic, grid middleware installation automatic, then local resource management system is also configured automatically. Then only job is submitted and the job is giving back the results also. Another important contribution in that CRB is semantic. We introduced semantic information in the CRB. See, actually whenever it is submitted to the request handler, we had the semantic descriptor. See, we had grid resource repository, cloud resource repository, and also OS metadata repository. Whenever the cloud resource is giving the virtual machine, the OS will also be selected, and that OS is automatically transferred to the virtual machine, and the virtual resource will be connected to the system. For that purpose only we are having the repositories, and whatever is available in the cloud resource, the parser will take it, then the ontology will be having the actual template. The ontology is used for creating the semantic knowledge base also. This is the actual description, semantic description of the resources. Actually, all the grid resources as well as cloud resources had been defined in the ontology template. The ontology template is a domain specific ontology. It provides the hierarchy of concepts along with properties to define their characteristics. Ontology is used for understanding the domain information. It describes the concepts in the domain and also relationships that grip between those concepts. And web ontology language or OWL has been widely used for creating ontology. In simple words, ontology means you are creating the knowledge base, or it is representing the knowledge. By using the ontology editor, it is possible to represent the knowledge. Once the knowledge is represented, then you can create the knowledge base. And Protege is the ontology editor we have used, and also once if you create the knowledge, it is essential to retrieve it also. So, knowledge acquisition as well as knowledge retrieval, these are the two major functionality in this semantic case. So, we acquire the knowledge semantically. Say for example, the resources will be having the software requirement. In case if it needs the Linux flavor, a particular thing, Fedora or CentOS or SUSE Linux or Red Hat, there are different versions available. The user is asking one type of version, but the actual grid is not having that version. In that case, we can check for the identical Linux versions which is having the kernel common, and that can be suggested. That is called as that ontology developed for this one. See, what is the actual machine configuration, what are the various softwares and applications available, everything was represented semantically using the ontology. Once the resources are represented in the ontology, whenever a similar resource is required, you can give it instead of the other thing. So, the main advantage is the semantic matching will help you to provide the resource which are equivalent to the actual resource that can be executed. So, in that way we have defined the semantic component. So, this is the ontology template in which we had the cluster, then we had the head node configuration, then software details, OS details, application details, and what are the various image details. all those things had been represented in a semantic manner. And the CRB with the semantic monitoring and discovery services, whenever you give the request handler will get the request. We had the semantic discovery module instead of the conventional discovery. So, we represented everything in the semantic knowledge base. The resource information, the cloud information, everything is updated periodically. The aggregated information is actually represented in the knowledge base by using the ontology editor. So, we represented the knowledge semantically. The actual resource information or the cloud resources as well as grid resources, everything was represented in a semantic manner, and we had the cloud controller for monitoring and discovery of the services. So, we had the Eucalyptus cloud middleware which was doing the monitoring and discovery of services. Since Eucalyptus was also developed as a service oriented, we were able to easily plug in our services into Eucalyptus, and from that we have also integrated with our grid middleware adapter. So, we wrote the adapter service so that it was integrated with this particular adapter service for the monitoring and discovery of services. This is the experimental setup we are having in our lab. So, the CARE resource broker is available. We had one site in which the grid resources are available. We had another lab in which the cloud resources are available. So, we were able to test it by considering the different systems in different labs, and the CARE resource broker will select the appropriate resource based on the requirement. So, this is the total functionality we have used. Actually, Eucalyptus is having the cloud controller, its storage controller as well as the node controller. These are the main components which are available. So, we have created the various nodes by using the Eucalyptus middleware. So, the actual cloud resources are created using the cloud middleware, and they were connected to the grid resources whenever there is a need. And also we wanted to test it with real world applications. One is GROMACS. Actually, GROMACS is a Groningen machine for chemical simulation. It is a powerful toolbox in the molecular modeling, and it was developed in the University of Groningen, and it is mainly designed for testing of biochemical molecules like lipids, proteins, nucleic acids, which has lot of complex bonded interactions. It is mainly used to understand the structure, dynamics and motion of individual atoms. The two most commonly used methods are energy minimization and molecular dynamics that optimize the structure and simulate the natural motion of the biological micromolecules. It converts the molecular coordinates from a protein data bank file into the internal format. See, when you want to simulate this one, we should know what are the various processes involved in simulating this particular GROMACS application. So, we have visited that website and we created the topology files using the protein data bank file, and then we had the solvating the protein, then energy minimization, equilibration run, then performing the MD simulation, viewing the trajectory files, viewing the MD simulation results. These are the various steps to be followed for the GROMACS application. Then we had the visual molecular dynamics based on the data generated. We tested this GROMACS application in our lab using the grid and cloud resources, and this is the simulation output for the data we obtained from that also. So, when we compare the execution time of the jobs in grid versus cloud, we had got the average time taken in grid, average time taken in cloud. Why we have compared? See, cloud resources are normally using the virtual resources, virtual machines and virtual clusters, whereas grid resources are comprising of only physical resources. So, to compare the actual time taken for this job completion for 10 nodes, it took 35.45 minutes, whereas for the virtual cloud resources 37.52. For 20 nodes 30.18, here 32, here 24, this is 28, 21, 24. So, matter of 3-4 minutes only. We have considered the less number of data because the ordinary PCs and clusters only we used in our laboratory. we did not have the big end computing. That is why we tested with 2 different labs having the small clusters formed with the help of our laboratory personal computers, and this is the result we obtained. So, even though we are having some overhead by using the virtual machines, the performance is not that much bad. That is what we want to prove. So, when you consider the CRB features, we had the JSDL, job submission description language specification for job submission, that is an XML file only, and it provides the graphical user interface for job submission, monitoring and viewing the resource information. We use semantic description and discovery of grid and cloud resources, so that it is possible to solve the interoperability problem. Since we are representing everything in the form of ontology, whether it is a grid resource or cloud resource, everything is matched by using the ontology. So, we were able to solve the interoperability problem using the semantic concept. We have tested with DAG job, that is direct acyclic graph type of jobs, MPI message passing interface jobs and batch jobs. All those types of jobs had been supported, and we have created the virtual cluster using the portable batch system or SunGrid engine as the local resource manager in grid as well as cloud resources. Whenever you want to submit a job in a cluster, you need the local resource manager to manage the various systems and get back the correct results. The capability to create the virtual machines on the fly will also improve the scalability. Let us have a short break now. Welcome back after the break. Now, we have done another application called agriculture application. Actually, agriculture and IT fields are to be merged, because the agriculture is another important thing which we have to consider in our nation and throughout the globe. There are so many applications possible, but we have taken a small application, defect detection in mango fruits. This is the problem we got. Actually, Alfonso mango, it is very famous in Konkan state, from Maharashtra state. Konkan is a place there. The Agriculture University in Konkan, Maharashtra also approached CIRI and worked in spongy tissue problem. See, Alfonso mango is considered to be the tastiest mango, but it is having one peculiar problem called spongy tissue. Outside the mango you will not see any problem, but whenever you cut it open you will be having some problem inside. So, it is the most delicious variety of mango. It is known for its golden hue, taste and aroma, and accounts for nearly 60% of the mango export trade from India. The Konkan region of Maharashtra, especially Ratnagiri and Devgarh, produces the best quality Alfonso mangoes. Our Indian Alfonso mangoes are exported directly from our family owned farms in the Ratnagiri district of Maharashtra, India. So, this is non-spongy fruit. See, in this mango fruit, you are having the clear picture in which there is no defect at all. When you cut it open, it is clear. Whereas, this is whole spongy fruit. While you see the fruit outside, you will not see any damage. Whereas, when you cut it open, inside you will be having the portion like this. So, inside the mango, you are having the spongy tissue problem. Whenever you export the mangoes, people expect 100% good quality. That is the main challenge. So, this is the trial at CIRI. CIRI is meant for Center for Electrical and Electronics Research Institute. They are doing lot of research in detection of surface defects in fruits as well as the defects in the mango fruits. Already they have developed the application for this Alfonso mango in C++. They have developed the sequential code. Our job was to create the MPI code by using the message passing interface. We developed the parallel code and we tested in that test bed. We were able to achieve the increase in throughput by using the virtual machines. I will tell you the actual setup available in that CIRI lab. This is the loader in which you can dump all the fruits in this loader. It is smoothly transferred through this belt, and this black box is nothing but the actual scanner which is used in the airport. Similar type of that one is available. Here, whenever the fruit enters, the image is to be captured, and the captured image should be segmented based on the area of interest. After that, you should have the various features extraction. After extracting the features, you should classify it is a good mango or bad mango. Really, we had a fantastic experience. Every year during the month of May, the university from Maharashtra, they dump the mangoes in CIRI office only for validating the mangoes. So, you are having the different mangoes passed through this particular scanning. The challenges are to do the image processing within that 30 to 40 seconds of time while it is traversing inside this box. Once if it is crossed, it has to be decided whether it is a good or bad fruit. Another important condition is you can allow any good fruit to be identified as a bad fruit, but no bad fruit is allowed to be identified as a good fruit, because the bad fruit is identified as a good fruit, the packing which is having the good fruits will be affected. That will affect our export condition. So, the main condition is good fruit can be considered to be a bad fruit, but bad fruit should never be considered as a good fruit. So, that was the challenge we had. Already they developed the program in the sequential manner. It is actually processed by the computer. So, we created 3 virtual machines in our test bed, and whatever images captured by them, we tested it in our lab. So, we created 3 virtual machines. All the 3 machines are clustered together. We submitted the same job by using our MPI code, then the throughput was increased by 50%. So, it was tested only with the 3 virtual machines. So, instead of a single machine available here, if you have the 3 machines available here, it is increasing the efficiency, throughput is increased. So, they thought of having 2 parallel fruits can be just transmitted, you can increase the number of virtual machines, like that it is possible. So, for this agriculture application, to have the better export conditions, this application was very much helpful. So, we should know how to apply our information technology for the purpose of using it in the agriculture field or any other field. When you consider the virtualization, it is used in so many places. See, for agriculture application, if you consider the wireless sensor networks, you extract the signals from the various sensor nodes and bring it to a computer. Once it is brought to the computer, then it is networked with all other computers through internet. You can process it in some other place using the back end computing. Whatever inputs are obtained from the agriculture fields, that can be processed for the defects available in the field, and we can immediately rectify that problem. If there is a big field, you cannot go and watch each and everything. We are having cheap sensors available, just you throw it throughout the field. Suppose if it is affected due to some disease, how to sense it? So, you will be having such type of sensors available. So, whenever it is affected, try to just distribute the pesticides to kill the particular bacteria or virus in it. Similarly, you want to see whether the water level is up to the mark or it is drained or it is overflowing. Based on that, you can have some type of sensor. Whenever the water is drained for the paddy field, then immediately you can switch on the machine. Once if you have the sensors, it will give the alert message to your mobile phone. Then after seeing that alert message, you can go and switch on the motor so that it will give the water flow. Suppose if the water is exceeding the threshold, then again you will be getting an alert message. You can drain it if it is overflown also. Like that, for agriculture purpose, cloud computing is playing a major role for helping the farmers and also for helping the customers in which area this particular crop is having more demand, in which season this particular crop is very much possible, and when can we have this type of plants, this type of cultivation, in which type of soil. So, everything we can just get the information. Once if you have the information available, then that information has to be simply parsed and it has to be discussed with the experts who are nothing but the farmers, and based on their expertise we can process the data and give the remedial solution to sort out the issue. In that way, cloud computing is helping the farmers, the users in a great extent. So, that is why I wanted to explain this particular application where virtualization has helped us to improve the throughput. And our other collaborations are with Athabasca University, Canada, University of Madrid, Spain, already I discussed about Gridway and OpenNebula. Then MIMAS, Malaysia, we have done one research with this MIMAS, which is similar to CDAC in India. We had virtualized the computing element. Their requirement was like this. They are having so many applications submitted to the grid as well as cloud. What they wanted was to create the virtual machine dynamically from the freely available physical server whenever there is a need, or to create the virtual resources from cloud environment whenever there is a need. So, they suggested to go for OpenNebula as the middleware for this creation of virtual machines, and also we used KVM as the virtual machine monitor for creating virtual machines. So, by means of these projects, we had the opportunity to work with Zen, KVM as well as VMware. So, by doing so many projects, we will be involved in different environment and it will be very much helpful. Then we have discussed about the Honeywell project where creation of the virtual machines. Then Siri India, surface defect identification of the fruits. Then with CDAC Bangalore, we have developed the semantic resource discovery. So, all those concepts I have partly explained in our research collaboration. Our current research focus is on SDN, software defined networks, SLA, we are having the service level agreements, then heuristic resource scheduling, distributed denial of services. These are the areas in which we are concentrating. Actually, when you go for cloud computing, that SDN is needed because network virtualization is to be considered, and we are using the storage virtualization supported by SAN, and the SLA we are trying to use the semantic concept, so that the service level agreement requires the negotiation of the actual quality of service between the client as well as service provider. So, first of all we should create the SLA where we are giving the requirements of the users, then SLA negotiation will take place, so that the SLA created will be matched with the SLA providers this service level agreement. Once the negotiation is over, both are compromising to have a common service level agreement. Once the SLA negotiation is over, then SLA is enforced. Once if it is enforced, it has to be monitored, and during the monitoring process, if there is any deviation from the agreement, automatically penalty will be given based on the problem with the particular resource provider. Suppose if the problem is with the user, means then for that also there will be a penalty class. So, the SLA is imposing the various policies, the various service level agreements which are to be guaranteed by the service provider. If they violate those norms, automatically penalty class will be implemented. So, when you consider the SLA, you are having the SLA creation, SLA negotiation, SLA enforcement, then SLA monitoring and penalty based on the actual mistakes committed or any problem encountered in that one. So, like that we are using that SLA, there also we are trying to use the semantic concept. Then the resource scheduling is another important field where we want to make use of the actual resources in an efficient manner. The scheduler will schedule the appropriate resource for the purpose of submitting the job. So, there are so many conventional first in first out scheduling, then backfilling scheduling, but these conventional will not be useful when you consider more number of parameters. That is why we are going for heuristic approaches such as PSO based, ant colony based optimization, then chemically reacted optimization, bacteria foraging optimization. Like that we are trying to make use of the heuristic scheduling approaches for the purpose of identification of the resources and the selection of the job. So, for the job scheduling as well as resource scheduling, we are making use of the heuristic resource scheduling. Then DDoS is another important topic. So, we are trying to identify the attacks as well as we are just trying to improve the denial of services, that is distributed denial of services to be identified, and for that also we are doing some research in that area. So, I want to conclude this episode to insist on the advantages or importance of the virtualization, which is useful in so many ways. So, when you think of cloud, it is necessary to make use of the virtualization, and without having the virtualization knowledge you cannot do research in the cloud computing area. That is why we have just explained the concepts of virtualization, different hypervisors we have discussed, different research areas in which virtualization can be applied, that is also given here, and just I want to conclude it by showing some of the sample snapshots of this research. That is our CARE resource broker, we have developed the login page. Then these are the various options you can have: job submission, status, usage, then submitting queries and resource list. So, job type, what type of job you are submitting, and you are submitting the job, the status is given, then matched resources are listed here. Then after submission of the jobs, these are the virtual machines created, and job output is also given. Now, when it comes to the future, there are three kinds of people: those who let it happen, those who make it happen, and those who wonder what happened. Those who wonder what happened, they belong to the users group. Those who make it happen, they are the implementers. Those who let it happen, they are the authorities who permit the implementers to do it. So, you can think of whether you are in this third group or second group or this group. So, you have to grow from user side to implementation side or developer side, then you should become the authority to allow others to do it. The future is already here, it is just not evenly distributed. You have to capture the opportunity whenever you want to do something great. It depends upon your self motivation as well as self learning process. So, you please try to identify the future which is available, and based on the recent technologies you can definitely do a better job. So, to conclude, we have discussed about the hypervisors, then software defined networking, storage virtualization, and the research focus in CARE center also. To review the various concepts we have discussed, you can just answer the following questions. Identify some of the storage hypervisors available in the market. What are the advantages of storage virtualization? What is SAN? What is the purpose of virtualization in cloud computing? If you answer these questions, you will be getting some ideas, and also identify some of the applications for cloud computing using virtualization. Thank you very much.